Hello students, welcome to the DME class. Today we will discuss the design of centrifugal clutch. Before design of centrifugal clutch, you should watch the previous video on the construction and working of centrifugal clutch. So let's start the design of a centrifugal clutch. So in design of centrifugal clutch, it is required to determine the weight of the shoe and size of the shoe. The following procedure may be adopted for the design of a centrifugal clutch. So two things you have to calculate in the procedure of design of a centrifugal clutch. One is weight or mass of the shoe and other is size of the shoe. So let's start first the calculation of mass of the shoe. So let M is the mass of each shoe, N is the number of shoes, R is the distance of the center of gravity of the shoe from the center of spider. So this is small r. For example, in this diagram, this rectangle shape represents the shoe and G represents its center of gravity and small r is the distance of center of gravity from the center of the spider. Whereas capital R is the inside radius of the pulley. This capital R represents inside radius of the pulley. So you can also understand from this diagram, this rectangular part is your shoe and the somewhere here will be its center of gravity and the distance of center of gravity from the center of the clutch will be small r and thus radius of this pulley is the capital R. Okay. Now N is the RPM, running speed of the pulley. Omega is angular velocity, which can be calculated from 2 pi n upon 60 radian per second. And omega 1 is the angular speed at which the engagement begins to take place. So let's understand this concept. In your centrifugal clutch, the shoe is acted upon by two forces. One is centrifugal force, which is acting upwards, and other is spring force, which is acting downwards. I'm only considering this shoe here. The spring force is acting downwards and centrifugal force is acting upwards. If the RPM of the driving shaft is less, then the centrifugal force will also be less and the shoe will not move outward, or we can say upward. But if the RPM of the driving shaft is high, then the centrifugal force will also be high and the shoe will move outward and touch the pulley like this. So there is a certain RPM of the driving shaft at which the spring force, which is downward, and centrifugal force, which is acting upward, both are equal and your shoe is floating, or we can say at this point the engagement begins to take place. So at this point where the engagement begins to take place, the RPM of the driving shaft is omega 1. This omega 1. So I will give you the example first. Suppose first your driving shaft is rotating at 100 RPM, which is very less, and the centrifugal force will also be less, and the shoe will not move upward. Then suppose you increase the RPM and your driving shaft is now rotating at 300 RPM. At this point, let's say the spring force and centrifugal force are equal and they balance each other and the shoe will be floating. At this point, the engagement begins to take place. Then you further increase the RPM and you increase the RPM up to 400 RPM of the driving shaft. Then the shoe will touch the pulley and the engagement takes place. Okay, so the 400 RPM is omega, 300 RPM is omega 1, where the engagement begins to take place. And Generally, omega 1 is taken as 3 by 4 of omega. Omega 1 is taken as 3 by 4 times omega. Okay, means if your omega is 400, your omega 1 will be 300 in terms of RPM, but omega having the unit of radian per second. Okay, mu is coefficient of friction between shoe and the rim. So now let's balance out the forces. The centrifugal force is acting upwards, so it can be written as PC, and the formula is m omega square r. Since the speed at which the engagement begins to take place, that is omega 1, is generally taken as 3 by 4 of the running speed. Therefore, inward force on each shoe exerted by spring is given by PS. Spring force is m omega 1 square r. So the spring force can also be written in terms of centrifugal force, but with the RPM of omega 1, which is 3 by 4 times the total RPM, total angular velocity. So m omega 1 square r. So omega 1 is replaced by 3 by 4 times omega, and it is calculated as 9 by 16 m omega square r. So the centrifugal force and spring force both are calculated. So the net force will be the difference of these two forces. Since centrifugal force is acting upwards, spring force is acting downwards, so the resultant, the net force will be difference of these two forces. So m omega square r minus 9 by 16 m omega square r. We subtract spring force from the centrifugal force, and the result will be 7 by 16 m omega square r. And frictional force, now this is your calculation of force. Now if we want to convert it into frictional force, just multiply it with mu, which is coefficient of friction. So frictional force or tangential force will be written as mu pc minus ps, and the torque on each shoe can be written as force into radius. So mu pc minus ps into r will be your torque, but the torque will be for one shoe only, and the total torque will be multiplied with number of shoes. For example, if you have 4 shoes, then multiply the torque with 4. So you will get the torque of 4 shoes. That means total torque. Now, in the next step, the other thing which you want to find for the design of centrifugal clutch is size of the shoes. For the size of the shoes, you should understand what is length or contact length of the shoes. So let's see this diagram. This arc length, curved length is the length of the shoe, L, small l. Okay. B is the width of the shoe, which is acting in a plane perpendicular to this screen. B is the width of the shoe. R is the contact radius of the shoe. It is same as the inside radius of the rim. This radius R, capital R, will be the contact radius, or we can say the radius of the pulley. Theta, angle subtended by the shoe at the center. This is the angle theta, which is the angle subtended by the shoe at the center. And generally theta is taken as 60 degree, or we can say pi by 3 radian. P is the pressure, which is generally taken as 0.1 Newton per mm square. So how will you calculate the size of the shoe? First of all, you apply the formula for the length of arc. So length of arc L is equal to theta into radius. So length of arc, this length, the length of the shoe will be radius into theta. So length of the arc is theta into radius. Theta is 60 degree or pi by 3 radian. So pi by 3 into r will be the length of the shoe. Area of the shoe will be length into width, area, and force will be area into pressure. So area is multiplied with pressure. You can find out the force. And what is the force on the shoe? We know that net force on the shoe will be centrifugal force minus spring force. So this net force you have already calculated in the previous step. PC minus PS, 7 by 16 m omega square R. So PC minus PS, that is force is equal to pressure into area. Area is length into width. P is pressure and this is force. So from this expression, the width of the shoe can be obtained.